seen me do various presentations in the past on the Felix Trolley. But we've obviously gone through quite a journey with this machine, from starting looking at actually getting it in the UK in 2017 to do some feasibility study effectively and making sure we can actually use it for on our infrastructure, to then obviously developing it to meet our requirements in terms of standards, etc. And then obviously at the moment we're now in a sort of deployment phase. So for those that may have not come across the machine itself, obviously isn't a picture of it apart from the little snapshot on the top left hand corner. It's not a measuring trolley, basically for S&C. Uses non-contact and non-destructive testing. So a combination of cameras and lasers really to look at profile of the rails, and then taking measurements every 2 millimeters as it travels through the rails of the S&C, and taking profiles and measurements as it goes along. So there's a couple of contact details there with obviously myself, but we're actually still working through from the R&D point of view, helping the actual deployment of this, which I'll explain a little bit later. So, next. This is a short video, which is from the actual training package that we've put together for Felix, but it just gives you a little bit of flavour about what it's intending to do. So I'll play this a couple of minutes long.
As part of our job to keep the railway running safely and reliably, we are introducing new innovative technology to help us do this. Felix is one such initiative. An automated measurement trolley that is helping us to automate how we inspect and measure switches and crossings. But like any high-tech solution, it needs careful handling and experienced operators. So let's bring you up to speed. Felix is an on-track, battery-powered, remote-controlled trolley. It has been engineered to support on-track S&C inspections on our infrastructure to our standards in place of routine manual measurement, in order to detect potential component failures that could become derailment hazards. This is vital for the safe operations of the railway. Felix is self-propelled, and it can analyze several switches in sequence. The Felix measurement principle is based on no-contact technology, using a combination of cameras and lasers to detect signs of potential wear or failure. Felix scans every 2 millimeters, and these are analysed in real time. Felix is a modular solution that can be assembled and disassembled in several minutes. It can then be operated on track by 2 individuals. The main modules are the central module, 2 wheel sets, the measuring module, safety bumpers, a battery, and the remote control. During the operation, Felix is remotely managed with a handheld remote control unit. This remote control unit has an emergency stop button and other features, ensuring greater safety to the operators. Felix stores, processes, and displays the data in real time via the system app, reporting all measurements via a track engineering form. To summarize, Felix brings innovation to the inspections of switches and crossings, making it faster and easier to perform reliable diagnosis and quality control, supporting operators' decision-making, and ultimately improving railway safety.
Let's move on to the next slide. Technology is great. There we go. So that was just a flavour of really where we've got to with Felix in terms of just a quick explanation about what the machine does, how it does it, and what type of construction it has. So Felix itself is obviously a modular system, which we've just talked about within that video. It comes in 2 modular transportation units, which is those 2 units you can see on the top left. So they have got 3 modules in them each. And then when you open them, as you can see on the right hand side there at the top, they've got little drawers for the actual modules to be actually stored in. It's just a convenient and easy way to actually mean we can move it around if we're going long distances with that type of transportation system, or we can actually put the individual modules that you've got there on the bottom right on the back of a flat back and take it to site in that format to actually make it easier to be able to unload and load, because obviously putting those transportation units on the back of a truck and getting them off at the other end, etc., if you're especially on site, then it could be a bit more of a problem than actually just using the modules in the format they are. And then obviously on the left hand side there's Felix actually as it's assembled. So its parameters, it's actually gives us in terms of its recording, etc. Resolution now of 0.1 millimeters, so very, very fine in terms of that, with respect of the type of measurements we take from a track point of view, which are usually down in millimeters really. It scans at that pitch of 2 millimeters. It can be extended if you wanted to actually change that figure, but that's the minimum it actually would use. Operated by 2 people. 6 elements there that we've gone through already. The lithium-ion battery, which clearly is a area where we've obviously had to look at how we actually store the batteries, how we actually get them charged, etc., in delivery units. And that gives us a run for around 6 hours working time. So we have 2 batteries with each unit, just in case there is a potential for it to actually be needed to be used for longer than 6 hours. Hasn't happened yet, but it's obviously helpful to make sure that we've got that possibility covered if need be. Operator temperature, you'd expect it to be sort of UK temperature range at the minute, although clearly with climate change things are changing in that sense, especially the higher temperature, but that's what we've got it approved for. When you're actually using it to transit from one place to another, it's got a maximum speed of 5 kilometers an hour, which is obviously around about walking pace. And then recording speed is 1.6 kilometers. We did play around with looking at see if we can actually extend its actual speed to 3 kilometers an hour in the areas where we don't necessarily need the 2 millimeters scanning pitch. So at the end of the switch toe heel, and between there and the crossing, where it's more or less similar to plain line, it could have gone up to 3 kilometers by programming, but we decided to actually keep it at the actual 1.6 kilometers an hour all the way through the S&C. And there's algorithms within the actual software itself to actually 3D construct the rail that it's actually profiled, and we'll show you that hopefully a little bit later on once I've changed over to another my iPad. Okay, just give you a bit of a background of where we actually started with Felix and where we are now. As I said earlier on, we've got a feasibility study in terms of getting Felix over from Italy. So it's originated from a company called Loccioni, who actually made Felix from a clean sheet of paper for RFI. And RFI, the network rail equivalent, the infrastructure manager in Italy, who were looking for some automated method to actually assess their S&C in a similar way to ourselves. So we went to trial development 2019 to 2023. It took us a little bit longer, obviously, with COVID intervening. We had quite an interesting time during that 18 months to try and actually make sure we were able to keep things going. But obviously with the COVID restrictions in the UK and Italy, it was a little bit interesting because they weren't necessarily aligned in terms of what we could do from the Italian side to come over to the UK and vice versa. So that actually added about 12 months onto the development of what we've got. But when we looked at it, from the point of view of the Italian network have got their Felix Hall ready and going. I think they've been in track now for about 6 years, I think, over there. They've got 35 of these machines across the whole of their network. But obviously with their measurements, we didn't need necessarily the same as them. We needed some extra measurements that the machine hadn't actually been programmed for. So they're the ones that we were looking to try and actually add. So switch rail seating gap, or hogging, as people may know that term, where the actual switch is not necessarily sat flat on the slide plate and the switches. We need to know what that measurement is because of other measurements that it links to. So we were asking to try and actually find out if we could actually record that. Squareness of switch, get my tongue in gear, squareness of the switch toes, where we're looking to see a measurement we actually can do manually, but it's not very often it actually is done, but it clearly has some performance criteria when it comes to the point operating equipment and a bit of on the track side of things, how things actually are working together or not. So that was something we think that would be useful to add into the software. Residual switch opening, which is on the play switch, where it isn't actually the switch blade itself is not sat directly up against the stock rail necessarily. So that's a measurement that our signal colleagues actually more interested in ourselves, but it's something we still thought this machine could actually measure, which it now can. P8 profile measurement. P8 is the actual most common wheel profile we have on the rail vehicles that are going down our network. So that's something we have on a manual gauge where we actually look at the P8 profile measurements in that sense. Gauge 1 and Gauge 2, they're particular gauges we use, for those who are not aware of those, to actually look at side wear for Gauge 2 and also the switch toe height at with Gauge 1. So they're two that we actually can look at from a profile perspective to put into the software. And back-to-back gauge measurements. In other words, this is looking at the field side of each stock rail and what the measurements are from one side to the other. And we wanted to put that in place because it's a key area to actually give us some indication as to whether we've got some base plate shuffle and maybe some screws that are actually moving around a little bit, and the gauge is actually a problem and it's not being mistaken for side wear on switch rails, which is something that has happened in the past with certain switches and crossheads. So effectively we looked at all this and asked Blockchain to look at it, and their initial thoughts were we needed to actually have a new module developed to be able to do all of these measurements. They went away and had a look at it and then came back actually progressively having looked at each of the measurements we were asking them to add to the software and said, well, actually most of it we can actually just make software updates and that should be fine. We don't need a new module. But the only one that they couldn't do was the actual measurement of the switch rail seating gap. So we said, okay, carry on and we'll have a look at that and see if there's a way that can be done, and we'll look at the module and what that means in terms of costs, etc. So we moved to a training panel we actually put together in Whiteboard to assess the actual use of the different parameters we were trying to actually add to the software and proving that they worked, etc. And that module you can see in the middle with the plastic cover on the top, that was the module which was only using the technology to try and actually measure the switch rail seating gap. It did work, but there were some areas where out of its control that would actually mean we might get a false reading, and that was if there was grease that wasn't cleaned properly on the actual slide plate or the foot of the switch rail, or even a clip from the switch rail heating that you might see on some of the switch rails that you see. It would pick up those as anomalies. So there was obviously a question mark about how accurate that would mean, that the actual readings that would give us. The other big factor was it was going to cost us an extra £60,000 just for that one module to measure that one parameter. So we decided to actually park that one and just continue using a step gauge to measure that seating gap that we have underneath the actual switch rail, which is not too much of a problem in terms of adding time to actually inspect the switches, because you have to visually still look at the switches and walk around the switches to make sure there's no damage, cracks and that type of thing, which the machine isn't able to pick up necessarily. So adding that onto the actual inspection didn't really mean that it was going to cause any more time that we're going to add to the actual inspection requirements over and above what the actual automated system could do. So this is the big area where we have had obviously quite a few question marks about people's perception of the machine, why are we actually changing it, what's the point, etc. And clearly it is trying to actually replicate and replace the manual inspection. Use gauges, which is obviously down to human factors and whether each of us look at the actual gauge where it actually sits on top of the switch or on the switch itself, and whether we feel it's actually a pass or a fail. So it's clearly a very human orientated area of actual inspections for the switch inspection, particularly as to whether our interpretation of what the actual gauge is showing us is a pass or a fail. Obviously with a machine, it's taking that decision making out of the equation, and it's actually just making that consistent decision based on what the software actually is programmed to do, and making that change, which means we've got more repeatable and reproducible data sets that we can actually use in. So that's the big change for us, but clearly we still have some resistance out there in terms of people looking at this and thinking, what's the point, why do we bother? Because I'm happy with my little manual gauge that I'm using, which is that picture on the bottom right there, with a feeler gauge, which is a piece of plastic effectively of 100 microns thickness. But there's obviously a little bit of a, again, question mark about how repeatable those readings are. So when it came to to the changes, I was thinking, well, I can actually explain this. And I used this at a PWI seminar last year when I did a presentation about Felix. And it's something that I thought, well, it's a big seismic shift in terms of using a manual gauge and then actually going all the way to something like Felix. We've basically gone that way because of the fact that Luciani were developing the machine. So it was obviously a case of we hadn't got anything, an interim measure of having a gauge with something on it that can actually do all this out automatically using laser systems or whatever. We've got something now that's approved for that, but obviously we try to actually say we can't just ignore Felix. We need to go through making sure we can actually get this developed and it meets our requirements. So effectively, I put this together saying, well, you might be thinking, well, where's he going with this? Banking? What's that going to do with things that we're talking about here? Well, it's just the actual shift of change of how things have occurred. So when I was a child, my mum used to have to go to the bank and draw cash out from the bank every single week for the following week. Bit of a pain in the neck. So how many people would think of doing that these days? They'd actually think, not a chance, I ain't got time. I've got too busy a life. So obviously, as that progressed, we then got to an ATM where you could go and to the hole in the wall, which you obviously still can do, get cash out. But obviously, that was quite a task in big cities sometimes because of the queuing, etc., that we still see sometimes in that sense. So then we started using card machines. Clearly, we're still using that. So that's developed a little bit further incrementally from the ATM to a card machine. And then now we're at internet banking, using our phones, etc., to actually pay for things. So in all intents and purposes, we've got very big shift to nearly a cashless society, which clearly is step changes through the actual system. But when it comes to using Felix, we have moved quite considerably because the only step changes that have happened with our gauges over the time that they've been in place is on the top, some of you might recognize on the left side the Pac-Man gauge, which is basically looking at your switch radius in terms of a potential derailment issue. The only change that happened with that is that left hand from the Pac-Man to the right hand gauge, very small change, obviously just made it a bit easier to hold. Then on the TGV8 gauge, it's actually on our track gauges, we had one line which was at 60 degrees, and then a few years ago we actually moved to 3. So we have 55, 60 and 65 degree lines on there now for various reasons in terms of what the standard says for our inspections and what actions we need to take. So that's it. That's all we've done. We're now moving seismically over to something that's doing this automatically. It's using software, it's using a combination of lasers and cameras, and it's automatically doing it. No human interventions needed apart from a few taps on an iPad screen. So a massive shift in terms of how people's perception is of using something like a manual gauge that they physically can see what's going on, they can physically see where they feel the actual pass or fail is, to a machine that's doing that for you. Yeah, quite a big change for people to get their head around in some cases. And that's the way we are with all the gauges that we've got there on the left-hand side. That actually, there's about 8 of them, when Felix can do all the measurements that those gauges can do all in one go. So we haven't got to have 3 or 4 hands to try and actually hold all the gauges we need to use, and how we actually move from manual gauge inspections to using something like Felix. Clearly, we are not changing everything completely to Felix because we're progressively moving forward with actual introduction of the machine, but clearly it's not everywhere yet. So we've still got a step way to go. So this is what we found really. Obviously, the one thing I wasn't clearly excited on when we started introducing Felix with where we are now is that top left picture is what's commonly seen where people go out and doing manual inspections, maybe using a mini prof or a gauge to actually get down on their hands and knees on the actual ballast in the grease and actually do a very close inspection at night. Obviously, as we've moved away from doing a lot of our inspections during the day, clearly not great. And the guys that we actually were talking to saying, oh, it's great, this machine's going to stop me having a backache all the time, and then my knees are taking a bit of a hammering when I'm kneeling down every few moments to go and have a look at the inspections of these switches. So human factor wise, there's obviously a bit more to it than just taking the actual human interface out of it, it's actually helping people stop having health issues that actually are progressively getting worse the longer they do these type of inspections this way. So, as I said, we've got a few areas where we've got barriers to how we deploy a machine. Culture clearly is a big thing for us, no matter what we change, whether it's something like Felix or whether it's anything else. It's obviously takes quite a long time for this industry to start accepting change and making the best out of it. Resources, obviously, one of the things that's came out of modernising maintenance, for example, has been a challenge in terms of how they can actually support the introduction of Felix. So it's not something we can actually have a massive influence on as a project, but clearly it's something we need to try and help where possible. And inspections is one thing where we've got obviously areas where people are looking at something like Felix for areas where we've got high population of S&C, so big station throats, etc., where you can get those efficiencies. But clearly, there's more to Felix than that. If you have some S&C out in the sticks and people thinking, well, actually, it's not really worth me my while going out and using Felix there, I understand that, but there's clearly some advantages in terms of the data it's recording, the actual reproducibility, repeatability, and also an audit trail saying you've actually gone out and done that inspection. So there are some areas where looking at this in a different way would help. For example, in Italy, they've mandated that every single S&C unit they have in their infrastructure must be inspected by a Felix machine at least once every 12 months. That's obviously a bit of a sensitive check, I guess, in terms of how they're actually inspecting those switches and making sure nothing's been missed. So this is the parameters that we're actually using Felix for. So it does a small number of track geometry parameters. It can do more, but this is what we have at the moment. So gauge, twist over 3 meters and cross level, and then the others, which we've just talked about already. The one thing I introduced as well, which was something I just thought about after we had started the actual specification, was looking at the height difference between our wing rail and crossing nose. The reason why that's been introduced is because if we have a differential height from new, we know what that parameter should be in terms of from one point to another. It needs to be at, say, 5 millimeters. It doesn't necessarily mean it is 5 millimeters, but if we start increasing that height difference to 6, 7, 8 millimeters, the acceleration the wheel sets put on the crossing nose means that the actual forces that are going through that crossing are getting bigger and bigger. The more batter and more change in height between the wing and nose that you actually see. So if you get forces that are actually, excuse me, above the actual capability of the structure of the crossing, it will then follow that you're going to get a crack. So clearly, this is a measure we aren't actually using in ANDA yet, but we're developing how we actually can use that to look at giving TMEs and frontline staff a bit more information about how they need to maintain their crossings. Excuse me. So this is just a snapshot from last year. The first deployed machine was in Sussex. Excuse me. And that's been going since about January. So we've had quite a lot of data captured from that, and it's been repeated over various different S&C units. And that's just a snapshot of things it's found so far. The one thing I'd just point out on there was one junction called Red Hill, which some people may or may not be familiar with. It was taking the actual delivery unit a whole year to inspect that junction properly. So I think they have possessions every 2 weeks on a weekend, Saturday night, to actually inspect some of the junction. So obviously that's a massive drain on resource, say 26 inspections in a year, or 26 possessions to try and actually inspect that junction. We put Felix through it once we'd actually got some plan of how it was going to navigate itself through the actual S&C, and it covered the whole junction in 2 weeks. So you can imagine the amount of possessions that can save if we start using something like Felix on examples like that. Clearly, that's a bit of an extreme example, but obviously that could be replicated around the country in different places. Just an example of what the efficiencies are that we've seen so far. So this is an example of a crossing, a switch and crossing unit, which we are using as a case study. It was one that was mentioned in various presentations, so apologies if people may have seen this before. But effectively, this particular point number in Horsham had a point where the point P profile in this case, which is the wheel profile we actually are concerned about, flange climb to actually derail a train, has an area here where we've got 2 points where it's below 55 degrees. Now 55 degrees is banter facing move, stop traffic going over that in the facing direction. But the point we've got here is because there are 2 discrete points underneath that red line, according to the standard, they have to be over 50 millimeters in length, the whole thing. Because that's below 50 millimeters in length, it wasn't classed as a banter facing moves. So we didn't actually have to do that and didn't affect traffic at all in that case. But obviously this is a warning that clearly this isn't going to last very much longer before we are in that situation. So this was done in February 2023. Moving to May of the same year, we came back and were recording over the same switch, and this is the result. So obviously everything had worn a little bit further, and those 2 points had joined up and were below 55 degrees. So clearly a banter facing moves issue. So clearly there was no proactive attempt to try and prevent that happening. Unfortunately, that's what we found when we went back. And then later, we can then go back and record it after it's been ground. So that was on the same shift. The grounding team were actually following Felix around at this time to actually then be able to do a repair. And clearly that's the result. So there's obviously a lot better profile that you can see there without that failure. Just showing you what Felix can actually show in terms of its measurement capabilities. And this was January last year, sorry. So it's just looking again at how the deterioration's creeping along. So this will give you an idea of if you actually start looking at data from one recording to the next, you can basically do some degradation trending and see where theoretically in future you can actually get to a point where you need to intervene before it fails. So this is giving you a lot more information as to how that degradation is taking place. So this is where I'm going to try my hand at my technology. I don't know if this is going to work or not, and go to the apps we've got. So on the right hand side, you've got the Felix app, which is one that actually connects to the machine. It doesn't work unless you are near a machine because it's got its own Wi-Fi. The Felix machine, that is. So you need to be connected to that machine through your iPad before you can actually link into the actual software. But on the left, there is a demo app we've got for training purposes. And I'm going to try and get that to work. So we'll see if that happens or not. Just try and stop sharing on this and then start sharing on my iPad. This is where my hopefully technology is not going to actually fail me, but we'll see. Again, just bear with me a second. Technology is a wonderful thing when you can join. To be fair, this might. That's helpful. It's actually moved. So if I move over to that, so okay, I'm looking at both screens. So okay, this is the actual live screen you can see there off the app. And I've gone in and after log in using a username and a password as you'd expect. Basically, this is the first screen you'd see. On the bottom right-hand side, you've got the Felix battery itself. So the actual machine tells you how much battery life it's got in it. It needs a field calibration every 20 hours. That's a jig that's actually with the machine that you put the measuring head on, and it actually does have some sort of rail shapes that it assesses using the actual lasers and cameras and just checks that actually it's reading correctly. So all these different parts of what you've got there will give you a result, indication of what the actual system can do. So I've just going to the survey part of it. Basically, this is starting where you need to actually look at a particular S&C unit. So it's talking about whether you're doing a normal inspection or a post-repair inspection if it's a switch. Let's just use anything we've got there. Oops, come back. Junction. Just pick any random number I can so I can actually show you what type of thing you can see from the machine. So now it comes up after you put the point number in, there's a turnout. So I'm saying it's a turnout, so we'll just leave it at that. It's the right-hand one, it's got the rail section. You need to put the mileage in, not actually in figures, it just says whether it's actually a higher mileage at the toe of the switch or at the crossing. So we'll just go there. Move down a little bit. All the ones with a little star and you need to actually populate, because if it doesn't have that information, it will not work properly when it comes to the actual data that's calling you. Once you put that in, you get a line saying whether you've actually, where you've actually saying that the machine's going to go, where it's going to record. Got seating gaps, tells you what point operating equipment it has, the switch size, excuse me, and the speed. That is an important factor because we've actually downloaded the data from the actual Ellipse database for the S&C that's actually for the section this has been programmed for. So if it's Sussex, excuse me, we've got all the actual database for their particular switch types and sizes, etc. The one thing we found when we actually went to Victoria Station, first of all, was a lot of the people, the engineers, were saying its Felix system was a bag of nails. It didn't work because it was giving them spurious results. It was rubbish. But actually, when we looked at it, the database that had been downloaded from the Ellipse system said that they had a 100-mile-an-hour turnout through the middle of the station, which clearly can't happen. So that meant that it was assessing that switch at 100 miles an hour speed. So the parameters it was checking were obviously very different from what it needed because the speed was wrong. So there's things like that that need to make sure we've actually got that information correct. So it's obviously a key factor to make sure the delivery units know that. So we can put manufacturers, that is. And then it's talking about, this is just an example again, looking at the crossing details. And now we've got all the details in there, so we can start a survey. This just gives a bit of an example. So there we go. It's just showing as it's going through the switch. This is the type of data it will show. It doesn't look exactly like this because clearly this is a demo, but it's just showing you what the track gauge is and the cross level is over those particular areas it's actually ringing over. It should stop in a moment or two. While we're doing that, we've obviously got the visual inspection still to do, so we can just type in no on that. Good. Yes, no. And that will do for that one. So if we want to look in the results, obviously look in the results section itself, and we can look at that particular switch. Just gives us a standard inspection. And this is the type of information it's showing you. So on the right-hand side, they aren't quite aligned up in this demo version, but you've got the different gauges, an R4 gauge, a 2GP8 gauge, gauge 1, gauge 2, and the switch radius gauge. And it's showing you there on the green lines where there's an area where it's not an exceedance, so it would be red otherwise. So we've got green, amber, and red. So amber tells you that actually there's something that's not a span-to-facing moves issue, but it's something that needs to be actually looked at closer because it needs some maintenance. Shows you there the actual TGP8 gauge, looking at the actual green, the lines we've got here. So we've got 55 degrees at the bottom, 57 degrees. That's just something we've added because of a temporary variation we've added, which I'll go into a little bit later, 60 degrees, and then higher up, we've got the 65-degree angle. So it just shows where the 2GP8 gauge is actually being assessed on the switch rail to see what the contact angle is. Then we've got different TEF forms that look at the stretcher bar gauges at different points, etc. So there's various TEF forms we can look at in what they look at. So if I wanted to look at that particular TEF form in its entirety, we have a copy of the TEF form as we would see it as somebody doing it with a manual check as we currently have. So this is more or less a copy and paste of that form. It's a little bit different in terms of the colours, etc., but it's got exactly the same format on it, so it's familiar to somebody who does the inspection normally. And you've got your red, green, and amber results there to show actually what you're seeing. And then it goes down to the bottom. So let's go back to that one. And what I wanted to show you, the last thing before we move on to the other parts of the presentation, is when we've got all this together, we said the actual machine is capable of doing 3D reconstruction. So I've just got to give it a little bit of a heads up here, I think. To this earlier, so just need to make sure it gives us a little bit of a. So now it's actually looking to try and find the actual section I've just put in there to give you the 3D representation. So this is the switch toe. You can see you've obviously got the stretch bar fittings. You can actually manipulate this around, have a look at the switch itself, at this area. The reason why we've got this in there is something we can actually look at the profiles that it's taken. Clearly these are every 2 millimeters, and it can look and it can give you an indication of what the profile looks like, if there's any damage or anything like that. So if I just go out of that and actually go to one more, we look at that's at the toe. If you look at the crossing nose, just do this again. We'll now look and try and get the section I've just put in again to try and actually show what that looks like as a profile for someone to check what the nose looks like. Just give it a few moments. There we go. So that's giving us a 3D representation of what the nose looks like. So you can see on the surface there whether there's any batter or anything that looks like it's got any damage on it. The little bit of shadowing, that's obviously you can see in the sort of black bit at the top, that's a little bit of a reflection issue with sometimes it's got sunlight in it. It doesn't happen very often, and we've got the software updated to stop that from being visible. But as you can see, you can manipulate this around and look at this view however you wish, and put in those parameters to make sure we can look at that. And this is something we're going to start using a little bit more in future to try to look at joining up data from something like Felix to anything we've got, areas where we actually need to look at these type of profiles to try and understand a bit more about the actual damage that's been caused. So that was a quick run through that. So I'm going to try and actually share my screen again, rather than actually using the iPad. Here we go. So hopefully that was interesting and useful for everyone to see. Get that up and running. There we go. So obviously, as I said, Sussex have had theirs for some time now. We've got 4 machines that the RD&I team actually bought to basically push the actual introduction of Felix. So Sussex have their machine itself, they're the longest. Wessex have got a machine as well. Anglia and Scotland, the other group have got theirs. And now what we actually did as the R&D&I team and the project team, we went out to all the routes and said, if you are keen and serious about introducing something like Felix, we'd like to look at your deployment plan, how you're going to manage it, how you're going to use it to get the best options from people who are more keen to actually see this actually introduced and working, rather than actually somebody who gets the machine and actually doesn't make much use of it. So it's a bit of a shame that if that was the case. So we went out and actually got all the routes that were interested to submit a plan of how they're going to use the machine, assess those, and hence we came up with these 4 particular routes that they've now got their machines. So this is obviously how it's actually been seen from Sussex's point of view. This is a little bit of old footage in terms of the actual detail here, but you can see there how it actually has been looked at in terms of how it can actually help.
Phil, just sorry to interrupt, but you're not sharing your screen at the moment.
I'm not. Oh no, sorry.
No.
That's
no worries.
Why am I going to do that? Technology, I'm wonderful. I'm going to do it.
Increasingly incompetent.
Yeah.
That's how I describe myself these days. Yeah, that's back now.
Good. Sorry about that, everyone. Always good at talking to myself. Right, as I was saying, Sussex have got their machine, and these are the areas where they've looked at. This is obviously a slide that's a few months old now. Things have moved on a little bit, but obviously they're looking at various criteria that what they feel as successes. So there's obviously quite a lot of areas where we can develop on things, but this is what we've seen from them first of all. There are some issues, so bringing in new technology is never going to be go as smoothly as you'd like. Like it comes and it works straight out of the box. We've had quite a few issues from the software perspective, but we've also had some feedback that from the different routes that have been using Felix so far and improved the actual software. So making it easier and better for their functionality. So it's not a case where we're just waiting for stuff to go wrong. We're asking in for feedback, and we've been out with this on shifts with various different people who are trained to use Felix. We're in Scotland early this year, helping them with the introduction of theirs, and there's a few issues that they have with the machine. So the company who make them Bloccioni have been so good in terms of their working with us in terms of issues that we've found. They've been very proactive coming over and from Italy and helping out, sorting out things. So there are obviously areas where we know it hasn't worked 100%. And we've clearly moved forward very well with Bloccioni, especially on software updates, which we have 2 a year anyway, to actually improve things. So these are things that have actually occurred. We had heavy grease in Victoria Station, particularly where actually the grease in the crossing flangeways was so bad it was stopping the machine from running through it, because it had basically a flange that needed to go into the flangeways, sort of a flange on the machine, that is. And it was grounding out on the actual taped on grease. So we've moved the flange from a fixed particular design to 3 positions to actually adjust its height. So if we have that issue elsewhere, we can actually do something that will help alleviate the fact that the machine ground out on that particular issue. Obviously, that wasn't a machine's problem. It's more an inspection and maintenance issue that obviously was something that's probably unique to Victoria Station in that case, but obviously was an issue that caused quite a few problems. Reflections from sunlight, so we've done some more honing of the software, or what you only have to reduce that down to very little issues from the software problems point of view. Yeah, trained staff is a problem. We've got now quite a large number that actually have been trained, considering how many we had this time last year. So that's obviously down to getting staff released. I think obviously, as I mentioned before, modernising maintenance has not helped there in terms of being able to have staff released to go on these training courses to start using the machine like this. Bit of a chicken and egg scenario, obviously. We've got people doing these inspections with manual gauges currently. They are the people that need to perhaps be released to go on these training courses to use Felix. But clearly the TME can't release them because he needs those staff to do the inspections. So it's a bit of a conundrum as to how we can get around that, because of that area where the resource is really strained in terms of having that ability to give people the time to go on the course. The competency wasn't live on NetRail's system on Oracle. It is now. That was, as I said, this is a slightly older slide, but that was something we actually had a problem where we had to tell people in Sussex initially that if Felix found a defect, you need to check it with a TGP8 manual gauge just to confirm everything's as it's supposed to be, which is clearly daft, but that's unfortunately where we were until the actual competency got made live on Oracle, which happened about 12 months ago now. So that's now no longer required. And lack of knowledge from locations where we haven't been to. So it's not just about using Felix, it's obviously the logistics of getting it there, how you actually can power it, charging the machine, storing it, etc., etc. So there's all those sort of things that had to be learned. And Sussex have gone through quite a learning curve, as are some of the other routes. So at the moment, there's obviously areas here that Sussex have found that they can actually improve things. So dedicated team. There was one main person at the moment that's using Felix, and he's going around different delivery units doing Felix inspections for them. So you obviously can't rely on that one person particularly all the time. Others on there, I'm not going to go into too much, but the dedicated van was something that was an idea that came up, and it's taken a while. I don't think they've actually got their van yet, but it's basically been designed to fit all the modules of Felix into a van rather than having to actually have the transportation units or just put it on the back of a flatback. So something a bit more secure. This is obviously a very expensive piece of kit. It's very, very accurate and everything. So we need to make sure people actually take care of it. Don't just throw it around like they do with track gauges. So it's key for things like a new van that's been designed for this to be used and introduced, which looks like we're going to get some copycats from the other routes to actually look at using that type of design in future as well. So moving quickly on. So obviously we knew there's some issues technically with Felix. So we've done quite a lot of work on how we can move forward. So continual improvements made in collaboration with the company who makes the kit. The training, we've done some work to try and actually look at different training arrangements, looking at more local training where we possibly can. We knew there's going to be potentially a barrier wave of defects because Felix is much more accurate than obviously the manual gauges. And we put an area, I think in terms of Sussex, they put a repair team with Felix to make sure if they could, they would repair the switch if it failed on the night. So it wasn't actually going to cause a problem for banter-facing moves issues, especially. Issues with grease, which is I've just talked about that, was something we actually obviously went through a bit of pain. Using business change rules and etc. There's a lot of stuff going on at the moment in that sphere, and looking at issues for getting people trained. So we've moved forward as a project to actually address a lot of those issues. We've also looked at supporting the routes themselves. So from a project team, we've actually done all these things so far. So lots of things going on in the background, even down to how much the actual unit costs, getting a discount from the manufacturer, depending on how many we may or may not buy in one go. So obviously economies of scale. And obviously as the R&D team have got through all these areas, we're looking at governance, community of practice. There's a pre-deployment toolkit, so lots of information in there. Deployment workshops and communications, obviously, about that with a Felix newsletter, etc., and that type of thing. So there's obviously, there we are with shift reports, etc., looking at how it's gone the night before, if there's any issues, what can we do to help resolve those with Blockchain themselves, and any issues from the point of view of actually making sure they get success out of the machine. Using the community practices, we've got the national one. The others are in their infancy at the moment, but it's really just trying to make sure we can actually keep generating interest and show what the benefits to the routes in particular that have got Felix they can actually take advantage of, and clearly advertise to other routes. This is actually what's happening elsewhere, and this is clearly something you could actually have as well if you actually wanted to go for buying a machine yourself. And the pre-deployment toolkit, there's lots of information that has been generated for people to actually understand a bit more about the impact of change with this machine from their point of view, all types of things about what Felix is, what tests it can actually fill out, etc., etc. So lots of support and deployment workshops. I should have been at one this morning that haven't, but unfortunately that got cancelled. So we're still moving forward with each of the different routes. We're looking at delivery units like haven't in the case of today, to actually go down and actually do a deployment brief with them before they start using the machine, so they can understand a bit more about lots of information over and above what I've talked through here. And even a common strategy. So we've got our own site on Viva Engage. And as I mentioned, there's a monthly newsletter looking at how things are moving forward every month, which obviously is updated with what's gone on the previous month. So what we're doing in the future, we haven't actually finished. This isn't a case where we can just say we've got 4 deployed, let's walk away and let them actually work as business as usual. We will get to that point at some point, but we're actually looking at how we actually try and move away from the TGP manual gauge. There's some other work going on with a different project, which is looking at a laser profile system, which has just been introduced from a company called Abtus, which is like a track gauge with a laser head on it. So it's a sort of an interim between our current manual gauges and Felix. We've put a temporary variation in place now to look at the actual point of contact between the wheel profile and the switch rails, which is what these machines can actually record, not using a 100 micron feeler gauge, which is what we were doing before. So just replicating what the manual gauge did on track. So there's a comparison between the two. Clearly that's going to change. We're now moving to a development, and we've nearly finished the actual drafting of it, an 053 module. So 053 is our derailment hazard standard for switch rails. So we're making sure it's showing how much of an advantage you can get by using the automated systems like Felix instead of a manual gauge. So it's going to make it more risk-based in terms of how we actually assess the effect on switch rails, especially when we can start trending data effectively. So we can see when the failures are going to occur before they happen, and clearly you should be able to intervene before we get to the stage where a failure actually does happen. The trending is the biggest issue. Obviously, we need to get more data to be able to show that, how that can be used and how it can be taken advantage of in delivery units, which is Sussex's key area at the moment. With data management, we're trying now, we've got a project in flight with II to get Felix data taken through 4G into Insight to actually look at how the trending data can be done through that portal instead of actually having to do it in each delivery unit. So they'll be able to just plug into Insight eventually, excuse me, and assess their degradation. So future developments, looking at 054 crossing profiles, so looking at how we can actually use this information to check the wear rates, the batter, the profile, areas where we've got this height difference between the wing rail and nose I mentioned earlier. Side wear, we can do that on plain line. We can use it on plain line for adding more geometry capabilities on the parameters we've already got. So we can start looking at plain line to use Felix to assess track geometry and things like side wear, and also measure black holes where we don't have track recording vehicles. So it's quite a turning into something like a Swiss Army knife as the more we can develop this. So that's end of the presentation. So I'll stop sharing and take any questions anyone may have.
Thanks very well. If you were in the room right now, we'd do a round of applause, but I don't think that'll work over the microphones. We do have some questions, so I'm not sure if these people are still on. We've got some virtual applause for you. That'll do the trick.
Useful, thanks.
So Kieran, if you're still on, I think we covered your point about the grease. Was there anything you wanted to add to that before we strike it off? No. Okay. It also says great product. Lots of love for the machine. Andy Folds asks, is the machine set up to report directly against Ellipse asset IDs?
It's not. In that case, it's got against MSTs. We've got some MSTs that have been raised for Felix, but we haven't got that to that stage yet. It's mainly the Ellipse database area, which is going to link into the Insight aspect, which we're currently working on. So at the moment, it isn't directly linked to that. They're the sort of links we've been looking at and trying to sort out, because that's the biggest headache to actually try and join all these software systems together. Yeah.
I think that there's another point here on joining systems together. So this is Mike Rodwell. Technology looks impressive, especially with the usage of point cloud data. Great work. First question, will this data from Felix be outputted to the intelligent infrastructure software, i.e. GeoRhythm, INM or similar?
It's going to be, I don't know exactly. I had a chat with one of the II guys yesterday to approve some area where we're looking at mainly the actual transfer of the data at this moment in time. There's a second phase of the information that's going into Insight, which will link to, excuse me, the in database, I think there's going to be some area where that's going to start being combined together, but we've got to do a step-by-step process through Insight with II because of the protocol they've got us to actually set up the actual transfer first, and then we can look at how that can be assessed more in terms of what we can actually link it to.
Right. Okay. The second question that Mike asks is, looking at the photos, the machine is static during working mode to record the data. Do you think future prototypes would look to join other dynamic recording machines, i.e. NMT, as an attachment, so dynamic measuring can be done at line speed?
There is, in Italy, they have a train, I went out to see it in 2019, so it's about 5 years old now. It's a bespoke platform called Falco. They have a pod on it which has all the measuring capabilities of Felix. So it's obviously something that can be put on a machine already. I think the Iron Fleet are being looking at going out to tender at the moment. They're obviously interested in looking at something that Felix can be used on that type of equipment. So theoretically, if we actually go down the road of having a platform that we can bolt different measuring systems to it, then we can incorporate Felix on the dynamic side. You're quite right. It doesn't measure it dynamic. It only weighs about 256 kilos.
Yeah. And Mike's last question was, how is the machine traversed to site?
Basically, you go to your access point as near as you possibly can do, put it together on the machine, and then it actually motors it down to the site usually. It's obviously not ideal to be having to go miles because clearly that's not the objective of the actual machine itself. So obviously the access point is one of the areas where it can be a little bit of a challenge, but that's what we're trying to actually make sure we actually identify with the sections that are going to use Felix. So at the minute it's looking at appropriate access points to actually get it on and off track near where they need to measure.
Can you carry a spare battery pack?
Oh yeah,
So yeah.
We've got two batteries with each one anyway, so they take
Right.
those out generally just in case one isn't actually.
So
enough.
if you do have a lengthy traverse, you can potentially swap out a battery if you get a bit stuck for the way back.
Yeah, you could do, yeah.
Yeah. Okay. Do we have any other questions? Anybody want to put a hand up, or doesn't look like it? Okay. Well, thanks very much. Oh, hang on, have I missed something? Kamal. Kamal, I used to work with Kamal a long time ago. Sorry for asking, is there any speed limit up to which this system could be used?
It's really down to the pitch that we've actually got it to measure at. So every 2 millimeters, obviously it can't go much faster in its current format. So 1.6 kilometers is basically the speed it can go at when it's recording because of that pitch we've actually got to actually do the slicing of each profile. If we wanted to expand that to maybe, I don't know, over 5 millimeters, you can then increase the speed that it records if you want to. But having said all that, if you're talking about how long does it take to actually do a full turnout, that's both normal and reverse, to record it around about 10 to 12 minutes once you've got people that are competent in using the machine.
Brilliant. Okay, we have no further questions. So thank you again, Phil. Really appreciate you joining us today. I'm not sure whether you're aware of what Steve Pearson's doing with this automated track geometry system, but
not 100%. I know Steve works in obviously TA now, so I'll see him now again. But yeah, I know he's basically looking at the Iron Fleet stuff. So I have had a chat with him, but I'll still need to catch up with him about potentially making sure this type of system's in the actual tender requirements.
Yeah. So for those of you that are interested in the work that Steve's doing, he'll be talking to us in 4 weeks' time about that system. So come back and join us for that one. Okay, we'll wrap it up there. Thanks everyone for joining.